Hi guys, so now we're going to look at complex fractions. Probably a review, but it's always good to go over and make sure that we all know what we're talking about before we add layers to it. So, complex fractions. First, I want to talk about why it's a complex fraction. A complex fraction is a fraction inside of a fraction, where there's a fraction inside the numerator or a fraction inside the denominator. Basically, everything you're seeing on the page. So we're going to go through technically. You could take the numerator, divide by the denominator. You'd then have to create, let's turn the binomials into monomials, and then you would be able to simplify. So an easier way that kind of does two steps in one is that we're going to multiply everything by the common denominator. So first, as I look at 1, I just need to put a little, okay? So I have denominator choices of 16, 1, 8, and 2. What do all of those go into? They all go into 16, so that's my common denominator. So you're going to go through big set of parentheses here. And really, I'm going to write it over here times 16, times 16, times 16, times 16. So that way I can see all four numbers. The other way, if they're like, what is she doing? I'm technically multiplying by what? 16 over 16 is 1. So I'm not changing the value of it. So in the first fraction here, I have 16 and I have x squared over 16. This 16 crosses out with this, and I am left with x squared. In this top fraction over here on the right side, 1 times 16, there is no denominators, so you're going to go ahead, just multiply them together. You're going to get x squared minus 16 as your numerator now. Denominator left side here, 16 going into x over 8. The 8 goes into this 16 twice. That's a horrible 2. 2x. Lastly, 2 goes into 16. I'm left with 8. 8 times 1. All right, now I'm going to scroll. Let's see if I can get it right. There we go. Okay. Now I've come down to a regular fraction. The numerator can break into x plus 4, x minus 4, because they're both perfect squares. And then the denominator, GCF right here, shaboom, shabang. I'm going to take out these x minus 4s. Now, again, when you cross out, just be careful. Just do whoosh, one little quick line. Don't like scribble like we never want to know ever, okay? We're not, I don't know. We're not censoring mail here. So just go through little line, okay? It's not like you're not by censoring mail. I mean, when you cross out your address before you put things in the trash type things. Anyways, come back here. So your answer is x plus 4 over 2. Now, do me the favor right now. Know to stop right now that this is the end. Do not be the person that takes that 2 into the 4. Okay? You cannot do that binomial, monomial. Please do not be that person. Okay? That's the end. Woo! That was fun. Love these. Alrighty. Now, guessing it, you're doing 2. I will do 3. Ooh, look at that. Look at that. Now, at first glance, you look at 3 and you're like, oh man, what is she doing? But really, I need a new color to entertain myself. There's really only one denominator that's besides 1 is the x plus 1. So guess what the common denominator is? Shabetzra. X plus 1. Bloop, bloop, bloop. Bloop, bloop, bloop. Bloop, 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 bloop. Okay. Now, Bridget, you have 3 terms on the denominator. I know, we'll get there. We'll deal with it. Do the numerator first. X plus 1 times 1. Well, golly gee, that's itself. X plus 1. Over here on the right side, the 4 over the x plus 1 going out, that x plus 1 crosses out with that 1, and I'm left with 4. Okie dokie. Now, denominator. This, is yucky. We'll have x times x plus 1. You've got it. It's annoying. Put the parentheses there. Okay, and I didn't cross anything out, which worked out, because now I've got a 1 there, so you're going to do minus 1. Notice I'm using parentheses because they're cool. And then lastly, so that takes care of that, nothing crossed out. The last term over here, x plus 1, and the x plus 1 down there, I'm left with minus 24. 4. Ask why I'm writing vertically, can't tell you. So, make it, I'm going to go over here because I'm not doing 4. Guess who is? You are. So I have x plus 5 in the numerator, zippity-doo-dah. Denominator, x squared plus x, that's this right there, minus x minus 1. Come on, x, there you go. Minus 24. Come on, 2. Okay, so x squared sticks. 24, negative 21. So I'm going to have x plus 5 over x squared minus x's go out. Woohoo! Big summer blowout. And we get to that. Name the movie. Can you name the movie? All right, so here I go. Now, this is not the greatest organization, so just do as I say, not as I do. Now, we're going to go, how can I factor this further? I'm going to break this into binomials. X plus 5, x minus 5, shaboom! And I am left with 1 over x minus 5. Woo! That was awesome. That was awesome, right? Okay. One more as a family. Here we go. Let me organize this. New color. What do I want? What do I want? Green. Okay. So take a second and look at this one and kind of assess what's going on. What am I going to use as a denominator? That's a 1. That's a 1. I got a 3x and a 9x. Well, 9x is what works, right? 3x goes into 9x. So, yeah, boop, boop, over 9x, doop, boop, boop, boop. And technically, that's 9x over 1 over 9x over 1, right? But that would just be sloppy and messy. So here we go. 9x times 4. I just pointed and you can't even see. Nothing crosses out, so you get 36x. Okie dokie. Over here, though, woot woot, this 3x goes in the 9x, and you're left with 3. So 4 times 3 is 12. Yes, loving it, loving it. Down here, 9x crosses out with 9x, right? So this is just 1, okie dokie. And then over here, I have x times 9x. Nothing's crossing out. I have 9x squared. Oh yeah. Oh yeah, I know. What time is it? Factor time. Okay, numerator, what comes out here? We're going to take a 12 out. Bloop, bloop. Okay, and I'm going to have 3x minus 1. Denom. Oh yeah, difference of two perfect squares. 1, 1. 3x minus, oh, this is a thing. They talked about this in the summer and it was crazy. What's going on here? 3x minus 1 and 1 minus 3x. Same, but different. If it was 3x plus 1 and 1 plus 3x, then it'd be no big deal because addition is commutative, correct? That means any order is fine. But this is not commutative because it's subtraction. They are a difference of, waiting, pausing, I'm thinking you're thinking of it, you've got it, -1, right? This and this, if you look at it, if I multiply this row by -1, it looks like that. So we're going to go swooshy, swooshy, and I put my -1 in a circle so I don't forget it. And I go -12 over 1 plus 3x. Boom! Be the kid that knows they're done. Be the kid that knows we're not going to go any further and the 3x does not go into the 12. Thank you. Now, I hope you've enjoyed this video. I have enjoyed it. You do 2 and 4. I forgot to give you the answers. Ready? You are doing work, time is paused, blah, blah, blah. And for 2, you end up with 6 over a. And for 4, you end up with x minus y. Woo! My hair got caught in my pen. All right. Have a great day. I miss you. Have a great morning, evening, whatever you're working on. Bye.